Hi, welcome back everyone to Mind and Maths. This is part 2 of the lecture on chapter 2 called Basics in the EMFSS subject guide for Mathematics 1. The first part of this lesson, I covered activity 2.1 till 2.9, and we're continuing from where we left off. And I will make sure that the lesson stays below 30 minutes. Okay, suppose the demand function is given by this. So this is the direct demand equation. It is 20 minus 2p. Remember, this is known as direct demand, because you will be studying introduction to economics as well at this point. So it's good to know that if you represent Q in terms of P, it's called the direct demand. And when you represent P in terms of Q, it's called the inverse demand. Okay, quantity supplied as a function of P is 2 over 3 P minus a 4. Okay, and this therefore is called direct supply. They want us to find the equilibrium price and quantity. So at the equilibrium, they're going to be intersecting. So both these lines, if usually we have price on the vertical axis, just for convenience, let's just write quantity on the vertical axis, price on the horizontal axis. It seems like the demand equation is going to be like this. Quantity demanded curve with a 20 intercept, and slope is actually a 2, so it means I should have a 10 here. And the direct supply seems to have a intercept which is a negative, so it's probably going like this somewhere. Okay, so that's just a wild sketch. So what they're asking for us is to find the point of intersection. So the question is asking for the coordinates of this point A. So let's solve them simultaneously. I know that at the equilibrium, quantity demanded is the same as quantity supplied. So there's no excess demand, there's no excess supply. Let's solve this. I'm going to equate these, and I'm going to be left with a 2 plus a 2 over 3 p, and 20 plus a 4, and 3 to the 6, 7, 8 over a 3 p, and then we have a 24. And I am so bad at tables, like you won't believe it. I'm so bad. 8 ones are 8, 8 twos are 16, 8 threes are 24. So if I make some stupid mistakes, you guys will have to forgive me, because my mental math sucks, my tables suck. Okay, 1 over 3p is equals to a 3, because 8 threes are 24, and therefore the equilibrium price is a 3 threes are 9. So we got the coordinate of the price over here as 9. Let's find out the quantity. We can put it in any equation. So let's just put it in the demand one, because that looks easier on the eyes. 20 minus 2p. So 20 minus a 2p is a 20 minus 2 into 9. 9 twos are 18, hopefully, and 20 minus 18 is a 2. So the equilibrium quantity is a 2. So since I put price on the horizontal axis, I'm going to label the equilibrium like this, and I'll say the equilibrium price was a 9 and quantity was a 2, and I'm done. I hope it didn't ask us to sketch this. It didn't. How kind. Let's go to the next question. Here we go. Yeah. The next question says, suppose the market demand function is given by this. Okay. Now this is the inverse demand, because this is price in terms of quantity. So this is known as what? The inverse demand function. I'll just write it down so it's easier to remember. Okay. And he's also given us a market supply function, which is a 1 plus 4q plus q square. And now it's asking us to sketch both of these functions on the same graph. I can actually have a wild guess at this as well, that we have price on the vertical axis and q on the horizontal. When q is equal to 0, then price is equals to a 4, and it seems to me that it could be going something like this, because it's kind of like a quadratic thing. And the supply, maybe, I don't know, I'm just guessing, could be going like this. I don't know. And we're asked to find, they haven't asked us to find actually the point of intersection. Anyhow, this was a wild guess. Let's both of them are quadratic, so the highest power is a 2, so it means that the maximum number of times it's going to cut the q-axis is 2 times. Let's just first focus on the demand curve. Remember, we need to find the intercepts first. So when the value of q is equals to 0, the value of p is simply 4 minus 0 minus a 0 square, so it is just a 4. So one coordinate is 0 and a 4. The next is when price is equals to 0, what is the level of q? So we have a q square plus q minus a 4 is equals to a 0. Okay, so since the signs are opposite, this is a plus and that's a minus, so what we can do is we can do a 4. Actually, what would be the roots? 4 ones of... I don't think we'll get the roots that easily. Let's just apply the formula. Minus b plus minus b square. B square minus a 4ac over a 2a. Yeah, the under root. This is the under root of a 17. 4 4s are 16 plus 1 is a 17. Yeah, that's why I wasn't able to find. Okay, for this I'll actually need a calculator, because one value is minus 1 plus under root of 17 over 2, and another value is minus 1 minus under root 17. But we can make a wild guess actually. 4 4s are 16, so the square of 4 is a 16, which is less than a 17, and the square of a 5 is a 25. So the answer of this is just some number between, like, maybe it's like a 4.1 something. So even if I don't have a calculator, I can still make a very good guess that maybe it's just some 4.2, 4.3, something very closer to 4 as compared to 5. So therefore, this is going to be actually a positive number, and this is going to be a negative number. So let's write these as my... Actually, let me just use a calculator. Under root of 17. Just hold on. An under root of 17. Oh, it's a 4.123. Okay, so therefore one quantity is going to be, let's minus a 1 and divide it through by a 2. It's a 1.56. And the other one is, let's just call it 1 and 2 to distinguish. We'll have, I'll have to do it again, under root of 17, and then I have to do a plus 1 divided by 2. So we have a minus 2.56. Okay, so now we have a nice coordinates. So when q is 1.56, p is equals to 0. And when q is minus 2.56, p is equals to a 0. Okay, so we're done with the first step. And now the second step was to find the critical point. And we can use the completing square method to find that. So let's do that. this is our equation. Okay, so first let's take -1 as common. So I'll get a q square plus q minus a 4. Okay, 1 divided by 2 is a half, so that tells me that I need to add the square of a half and then also subtract a square of a half. Okay, so then I have a q square, q plus half square, and over here I have a 1 over a 4 minus a 4. So 4 4s are 16, and then we have a -1, so we are going to be left with a -17 over 4. Okay, square, so we have a -17 over a 4. Now if we open up the bracket, I have a minus, which indicates a maximum point. So I was actually wrong about my guess diagram. It's a maximum point. Shame on me. I don't deserve to live anymore. Anyhow, I need to learn how to be not cruel to myself. Okay, so this indicates that we have, since it's negative, therefore we have a maximum point, and these two right here tell us the vertex. So the vertex is simply a -1/2 and a 17/4, and 17/4 is 4 4s, so a 4 and 1/4, so a 4.25, and a half is actually a 0.5. So there we have it. So making a rough sketch of this, actually we have negative numbers, so cooperate with me, iPad. Okay, so we have a 4.25 here, a minus 0.5 here. This is our vertex, which has to be sort of like a maximum point. And the other points, we had a 1.56 and 0. So over here, let's just assume this is a 1.56, 1.56. What was the other point? A minus 2.56. Let's just say this is a minus 2.56. And there was another intercept, which was 4. Okay, great. So we have another point here, which is a 4. So making a very rough diagram, which isn't drawn to scale, is this. So this is what the demand function looks like. And remember, it's not actually possible to sell negative quantities or sell at a negative price. So the only part of this which is relevant to us when it comes to economics is just this part. Okay, so we're done with the price demand in terms of quantity. Okay, moving on to the supply curve. What was the supply curve? It was this. Let's just copy it down, and I'm gonna try to speed things up so things don't get boring. Okay, let's go. When the step 1 was intercepts, take P is equals to a 0, and you'll get a 1 plus 4q plus q square is equals to a 0, and we can just use the quadratic formula to find the value of q, which is a minus b plus minus a b square, which is a 16, minus 4ac over a 2a, and therefore we have a minus 4 plus minus and under root of 12 which would be like if 2 2s are 4, 3 3s are 9, 4 and 4 4s are 16. So it's somewhere going to be around, like it's going to be between 3 and a 4. So yeah, let's just approximate this. Suppose it's a 3.5. So one value of q is a minus 4 minus 3.5 over 2, and the other, which is a 4567.5 over 2. Let me just use the calculator. 7.5 divided by 2 is a 3.75. So we have a minus 3.75 and 0. And another is q is equals to a minus 4 plus 3.5 over 2, which is now a minus 1.5 over 2. And that's just going to be 7 14, 0.75. So we have a minus 0.75 and 0. And finally, we need to find the vertex, for which we can represent this by completing the square. So we can write this as q square plus 4q plus 2 square minus 2 square plus a 1. So we have a q plus 2 whole square minus 2 2s are 4 plus a 1, which is a 3. So q plus 2 whole square minus a 3. So therefore the vertex is a minus 2 and minus 3. And since the attached value is greater than 0, so therefore this is now going to be a minimum point. So I'm just going to make sort of like a wild rough sketch of this. Obviously you are required to make a tidier one in which everything is drawn to scale and both of these diagrams are done together. So I'm just making an estimate. This is let's suppose a minus 0.75, and suppose this is a minus 3.75. So we have these 2 points, and then we had a 1. So suppose we had a 1 here, and we have a vertex which is a minus 2 and minus 3, so something like this. And therefore we have a supply curve. Yeah, it's supposed to be a bit nicer than this. And again, since we cannot sell negative quantities and we cannot have a negative price, therefore this is going to actually, just the relevant part for us is this part. So we've done the sketch. Did it ask for anything else? Yeah, we've done the whole question. Let me see if I should solve this one as well. Yeah, I think we should solve this one and then we'll end the session. It says find the break-even points in the case where the total cost curve is given like this. So this is the total cost, 2 plus 5x plus x square, and the total revenue is given as 12 plus 8x. So the break-even points are basically where the profit is equals to a 0. Yes, so profit is actually, the profit is equals to total revenue is equals minus total cost, and you're breaking even when your profit is 0. So that's going to happen when total revenue is equals to total cost. So we have 12 plus 8x is equals to a 2 plus 5x plus x square. So we have a x square minus 5, 6, 7, 8, a 3x. 2 minus a 12 will be a minus 10 is equals to a 0. And let's just use the quadratic formula. Minus b plus minus b square minus 4ac over a 2a. So we got a 49, 7 sevens are 49, and therefore the value of 1x is equals to 10 over 2, therefore a 5, and the other is a 3 minus a 7, which is going to be a minus 5, oh, minus 4 5 4, 4 5 6, yeah, and therefore a minus 2. Since quantities cannot be negative, so this is invalid. So the quantity at which it's going to break even is 5. So the answer has to be a positive number. So therefore, it's a 5. I believe that's enough for today. In part 3 of this series, I'm just going to continue solving the questions, and I think the activities are actually completed. Let me open the study guide. After the activities, we have, I believe, sample examination questions and then some other questions as well. So I'm just going to solve these sample examination questions and also these practice questions. So see you in the next class. Take care.